Okay, boys and girls, in example 7, we're going to do a combination of both finding angular and linear speed. According to the formula, angular speed is central angle over time. And of course, central angle is theta over t. Okay, so let's get started with the first example. Okay, boys and girls, we're going to use extra example 7. It's in my book, but it's not in your book. Okay. Again, I try not to use the same examples in your book so that way you have more examples to refer to. Okay. So here it reads: the circular blade on a saw rotates at 4,200 revolutions per minute. In part A, we're going to find the angular speed of the blade in radians per second. Okay. And that's part A. So let me show you part B. Okay, in part B, I'm trying to cover the answers, guys. In part B, they want the blade has a radius of 6 inches. Find the linear speed of a blade tip in inches per second. Okay. All right. So now let's get started. Okay, boys and girls. So, remember that the information given for us to find part A was 4,200 revolutions per minute. Okay. And remember, angular speed is theta over t. Okay. So now I'm going to give you kind of some side information that you have to remember. Okay. So remember that the arc length is 2 pi r. Remember, it's the same as the circumference because you're going around the entire circle. So 2 pi r, okay? But don't forget that the arc length is also the same as r theta. So if it's the same, then you have to imagine theta must be 2 pi, okay? So remember that. Theta is 2 pi. Um, as well as we know that if we wanted to find theta, that would be the same as S over R. And S is arc length, which is 2 pi R over R. And of course, the radius cancel out, okay? So, which will give us just 2 pi, okay? So there's so many ways to remember that, okay? So theta is the same as 2 pi. You can get that here, and you can also get it this way, okay? So this is what we're going to use, okay? So let's go to the formula again. So like I said, I showed you what theta is. Theta is 2 pi. And this is not the only thing we're going to do. Since we're given that it's 200 revolutions per minute, since theta is 2 pi, we have to multiply that by 4,200, okay? So let me put that in, 4,200. And of course, theta is always measured in radian, so we're going to put rad, okay? And then t, remember they wanted us to find per second. So for time, we're going to put 60 seconds, okay? And now to get the angular speed, all we're going to do is simplify this, okay? And if you simplify this, you should end up with 140 pi, and it's rad per second, okay? And you can leave the pi in there for angular speed, and that's fine, okay? All right, guys, and now we're going to move on, and that was the answer for part A, okay? So now we're going to move on to part B. If you recall, the formula for linear speed was arc length over t, okay? Here's the nice thing about this is that if you recall, S is the same as r theta, and you already know what theta is because you found it up there, okay? So your radius is 6, and that's given. Okay, this was given to you. 6 inches. So we're going to put 6 times our theta, and literally we're getting our theta from the top. So 42 times 2, that's 8,400. So 8,400 pi. Okay, and then our time, same thing. We want it in seconds, so that'll be 60 seconds. So 6 times 40, 8,400 pi over 60 seconds, okay? And with linear speed, go ahead and just multiply everything through, including the pi, okay? And if you do that, you get approximately 2,639 inches per second. Okay, don't forget that the unit of measure there is inches. Okay, so that's angular speed and linear speed. Okay, so now I'm gonna have you guys try the checkpoints, both checkpoints on example 6 and 7. Okay, and this should be able to help you do a couple of the problems on the textbook. All right, guys, good luck.